Hi everyone, my name is Nils Lowie, and in part of my thesis I'm searching for a way to see what dredging does on the Belgian continental shelf and how we can monitor it more closely. So why and how are dredging activities monitored? For several decades already, the Belgian continental shelf has been exploited for its sand, and this has implications for the seafloor and also for the water column as sediment plumes are formed. The monitoring of this has been done by the Continental Shelf Service of the Belgian government, as it is obliged by law. In this research, I mainly used the EM 2040 echosounder multibeam system on board of the Sediment, and all the data I'm going to present here are preliminary from a September campaign in which we closely followed dredging vessels during dredging, and those were trailing suction hopper dredgers, and in this presentation we followed the router. So the study area is the Belgian continental shelf. You have the router. We followed closely with the Sediment, and the router was not very keen on being installed. The first direct implications of the dredging we can see on the bathymetry, where we see the dredging trace here already. If you look to the backscatter, we again see the dredging trace, but also a halo of high scatterers here, which will be investigated further. Dredging does not only have implications for the seafloor, but also for the water column, as sediment plumes are formed. By trailing suction hopper dredgers, two types of plumes are formed. One caused by the drag head, and the other one is due to the overspill. How do we look into this sediment plumes? As done by looking at water column data of the multibeam. We are mainly interested in this blue part with the white scatterers, as this is the sediment plume, and we can mainly compare it with an echogram. It's the same principle, only now we detect sediment plumes. We can make nice visualizations with this, where you see the input of the overspill, and here the seafloor detection and the plumes due to the dragging. You can make visualizations across and along track, and as you can already see, this takes a lot of storage space, so a lot of storage capacity is needed. If you want to look to it in a more mathematical way for further processing, we first have to filter out the interference. So we have side lobe interference and multiples, so that's all the red and the yellow. We filter that out, and then next we do some sort of echo integration, in which we take the vertical mean intensity and then project this onto a grid, which gives this, and this is a map of the intensity of the plume. So what am I going to research further for the next months? This the correlation between the seafloor backscatter and the water column backscatter. Also the distance in space and time between the dredger and the survey ship, and its impact on the water column backscatter will be researched. And this is actually part of a larger research in which on the long term we want a model to pass from acoustic data to concentration of suspended particulate matter in the water column. And at last, some acknowledgements. I want to thank my promoters and co-promoters for their work, and the crew of the Sediment. If you want more info, you can always contact me. Thank you.